Hi everyone, welcome back. We're going to continue our discussion on inverse functions in this video by looking at how we actually find the inverse function. How do we work it out? How do we determine what the rule is? So let's start off by looking at an example here. All right. Now it's very, very easy. Okay, very straightforward. It's just algebra. Okay. If you know the equation of your original function, then the equation of the inverse can be found by swapping the x and y values of your original function, then solving for y. Okay? So all you've got to remember is that when you see f of x, that's exactly the same thing as y. Okay? So you've got f of x equals 2x. It's the same thing as y equals 2x. Okay? So what we're going to do is we're going to find the inverse of this here. F of x equals 3x minus 7. Okay, so the simplest way to do it is to pretend this is a y and then swap the x and y around. So we've got y equals 3x minus 7. We're going to swap the x and y. That's what I've done in the second line here. So we'll go x equals 3y minus 7. And now your job basically is just to solve for y. Okay, so here I can add 7 to both sides. I basically get 3y equals x plus 7. And then divide both sides by 3 and I get y equals x plus 7 over 3. Done. Okay, therefore, your inverse has a rule of x plus 7 over 3. Done. Okay, that's all it is. Okay, swap your x and y values, solve for y. That's all you're doing. All right. And again, let me remind you, this will only really work for one-to-one functions. Okay, so one-to-one functions are functions such that for any given y value, there is only one possible corresponding x value. All right, so here we've got a linear graph. Linear graphs are always one-to-one. Okay, whereas something like a parabola, a quadratic graph, that is generally many-to-one unless you restrict the domain. So here's an example of us trying to find the inverse of a many-to-one function such as f of x equals x squared. So again, we go through our process, swap the x and y, so I end up getting x equals y squared, and solve for y. Now to solve for y here, we've got to get rid of the squared, so we square root both sides. You end up getting y equals plus or minus square root of x. And here we run into a problem because we don't know which version of this equation to use. Do we use the positive square root of x or do we use the negative square root of x? There's nothing here to tell us which one to use. Okay, so trying to find the inverse breaks down in this way because we don't have enough information to pick the correct one. Okay, and it's all got to do with how you define your domain in the original function. Okay, so let's just quickly go through and see how this would work if we did define the domain of our original function. So let's say the domain of our function, let me write it up here. Let's say we've got function f. So we're going from, let's go 0 to infinity. Okay, so let's say that's our function definition, and you can see that the domain is from 0 to infinity. So if we were to sketch this, we'd get the right half of the parabola. Okay, so think about what happens if we were to now try and find the inverse of this particular graph. Okay, so think about how our function machine works. Let's say I put, so here's my function machine f, here's my function machine f inverse. So let's say I pick an x value of 2. So I put 2 into my function. It will spit out a y value. What's the y value here? Well, according to my rule, I square it and I get 4. Okay. Now if I put the 4 into my inverse, remember your inverse just spits out this original x value. And there's only one possibility for the x value that it could spit out. In this case, it's a 2. Okay. So notice that it's always going to be spitting out positive values. Okay, no matter what value you put into your inverse, it'll always spit you back out a positive value. Okay, because this half of the parabola only has positive x and y values. There are no negatives involved. So that immediately tells us that we don't need the negative sign here, and so our inverse rule is simply just y equals the square root of x. Okay, so the inverse of this particular thing would be square root of x, because we've defined the domain of our original function in such a way that it would only give us that possible option. Let's do it the other way now. Let's define our function's domain to include the left half of the parabola. Okay, so if I just rub all of this stuff out, start again. Let's say our function is from negative infinity to 0. So our domain is now from negative infinity to 0, which corresponds to the left half of my parabola, up to there. Okay. Now let's do the same thing with our function machines and see what happens, what type of values it's going to give us at the end of our inverse. So if I choose a value of negative 2, okay, and I put that into my function machine to figure out what the corresponding y value is, well, negative 2 squared is 4. So that gives me a y value of 4. Now if I was to take that y value, put it into the inverse function, it should tell me what the original x value was. Now there's no confusion about what that original x value was because there's only one possible answer. Okay, whereas if we had the whole parabola, it'd say, ooh, there could be a 4 here or a 4 here. Do I spit out a 2 or a negative 2? Okay, that's what we saw in the last video. But in this case, because we've defined our domain so that we're only considering this left-hand part of the parabola, there's only one possible answer for my inverse to give me, which is negative 2. Okay, and you can see that you can choose any y value you like along this left-hand part of the parabola. It'll always spit out a negative value, which indicates to us that your inverse will be the negative version of the square root of x. Okay, so it all depends on what the original domain was. This is starting to get into some really deep stuff. Okay, you'll explore this more in year 12. For now, just know that your function has to be 1-to-1 if you want a very straightforward way to figure out the inverse. Otherwise, you've got to play around with the domain of the original function so that an inverse actually exists. Okay? Cool. So that's all we wanted to talk about in this video. I will see you next time.